Burgess here, and we have been given some data here in the form of X and Y. We've been asked to graph ordered pairs, find the line of best fit, graph the line of best fit, and calculate R. And all the work's already done here because I recorded this video and my audio is all screwed up, so I'm going to re-record it, but there is a lot of writing numbers out, and so I am going to keep this here because I really don't want to rewrite all these numbers. So, okay, let's just start at the very beginning. We've been asked to graph ordered pairs. So the first thing you're going to need to do is you're going to need to draw an axis. So here's our y-axis, here's our x-axis, and we need to look at how much space we should give on our axis. So if we look at our x values, the lowest one is 16, the highest one is 33. And so we could get there easily by counting in fives. And my graph paper just so happens to work out that there's 5 spots in between everything. So that's the scale I chose to work with. But you could choose to count in tens or in twos or whatever. And so what I have here is I started at 15, and then I went 15, 20, 25, 30, 35. I just counted up to the highest number I would need for x. Then I labeled my axes. And if my x value had like a name, like maybe it was the age of people, then I would put like age here or whatever. But in this case, I just gave myself the name x, so all it is x. Now for y, similar story. We need to figure out how we want to count these out. If we look at this, our lowest value is 82 and our highest is 105. So I figured we could count by fives here as well. So I started at 80 and then I went up to 105. And then after that, what you need to do is you need to start graphing the points. And don't forget to label your axes as well. So now we start labeling points, and so we consider them in ordered pairs, 30 and 105, 20 and 89. So on x we go to 30, and on y we go to 105. So if we look here, we say, okay, well here's x, we go to 30. So this is 30 right here. Then we go up to 105. So this is where 105 meets 30. And on that one, I even labeled it. I labeled the first one just to show you. If you wanted to, maybe you don't have exact points like I kind of do here, then you could go ahead and label it just to be extra clear with whoever's reading your work. So the next point is 20 and 89. So we would come over to 20. So here's 20. And we would go up to 89, which is right here. This is where 89 would be on this axis. And we would continue on doing it for all of them. So we do 16 and 83. We'd go over to 16. So this is 15. So 16 is one more over. And then 80, this is 80. 83 is just, here's 81, 82, 83. So this would be 83. But again, if you don't have the exact points, then you can just sort of guesstimate, put it closer to 85 than to 80, that kind of a thing. And that's all you do for these. So you just go ahead, you graph all these points, and you should wind up with a graph that looks like this. And just looking at where the black dots lie, we notice that if the black dots are, if we have a lower x value, like if we have an x value of 20, we're going to tend to get a lower y value. See how y is lower as well? So if we have like, oh, look at this, 16 is only 83, very small. But over here, if we pick a larger x value, such as 30, then we get a larger y value. And the same holds true right here. So we notice that as this increases, as x increases, y tends to go up as well. So we have what we would call as, what it appears to look like is a positive linear correlation. All right, so now what we're going to do is we're going to jump on to, so that's part A, just graph the ordered pairs. So don't even worry about this red line. We don't care about it yet. Part B is to calculate the line of best fit. And then they give us this line. So there's actually another way sometimes people write this line as B plus AX. So just be aware of that. So when you get equations for A and B, make sure you have it for the correct line. Sometimes they're flipped. So okay, having this equation, there's two ways to do it. We can do it by hand, or we could do it by the calculator. And for parts B and D, we are first going to do these using the calculator, and then I'm going to show you a hybrid method, and then I'm going to show you the straight up manual way of doing this, because Each teachers have sort of different amounts that you're allowed to use the calculator by. So the first way is, first we got to put our x and our y data into the calculator. So if we go to stats, oh well, turn your calculator on, go to stats, and then we want to go to edit, and we're going to put our data in. So here I've got the data already put in. So list 1 has all of the x values, and list 2 has all of the y values. So it's got all the values already. And so once you have them in here, and they should match. If they don't match, you could run into problems. Okay, so because that means that you have like an x without a y. That's like, what the heck happened there? So okay, once we have that, we're going to go to a stat test, and it's going to actually produce A, B, and R for us all in one shot. It's amazing. So we're going to click stat, go over to tests, and then come down to our linear regression t-test, F. So we're going to do that. Make sure your x list and your y list are correct here. Everything else you can kind of ignore, and hit calculate. Now it's going to spit out an A, a B, and also there's an R right here. So we've got part 4, D, calculate R, boom, there it is, there's R. And if we look down here on my part D, I wrote it out right here. R's 0.83. This is pretty close to 1. It's not super close, so it's addressed in medium linear relationship. It's not like super strong, but it's not weak either. So 0.83. Now looking at A and B, well, for B we have 1.15, and for A we have 62.65. So there's A, there's B, and then we just fill that into our equation, right? Because our equation was y equals A plus bx, and so we just put A where A went and B where B went, and that's it. Boom, equation. And if we look up here, we see that it actually matches. Y equals A plus bx. So we know that this is how it goes. If it had it flipped, then we would flip ours. And there's actually, in this calculator, there's a spot where they've actually got them flipped. So I'm just not going to show you that one because at Citrus College, we use this one, at least in every class I've helped with. So, okay, we've got that all set up. Now what it wants us to do is, we've already done D and we've already done B, but it also wants us to graph the line of best fit. And so in order to do this, what we need is we need 2 points on the line, right? Because if we have 2 points, we can draw a line through those points. So all we need is 2 and we're done. So on your x-axis, you want to pick values that are already on your x-axis. So if you pick the value of 15, that's going to give you our first point. And after I did it, I probably should have picked something like 17 or 18, and you'll see why. So here's 15. I picked this for my x. So I can plug this in, and I can plug all these numbers into the calculator and get a y value. So if we do that, if I type in our equation here, 62.65, and then I add 1.15, and for our x value, I picked 15, and I hit enter, I get 79.9. So this is our y value. This is what when we plug all these things in, that's what y equals. Y is equal to whatever this is. And so we got 79.9. So this is our first ordered pair. When we pick an x of 15, we get 79.9. And this is actually a little below 80. So this point's slightly below 80, like just barely, which is why I maybe should have picked like 16 or 17. But that's totally fine. We just acknowledge that the point's a little bit below 80. And then up next, I chose 30 for my next point so that I had a point like sort of out here to make it easier to draw. So all you do is you come up to what you just typed in. It's the same formula, only x is 30 now. So you just plug in 30 here and you hit enter. And we get 97.15, which is what we have here. And then you just put the 2 points down and you just draw a line. Just grab a ruler or whatever and just draw a line right through them. And then it's good courtesy to label your line. So this line is the equation y equals 62.65 plus 1.15. Meaning that if you pick any x value on this line, it will satisfy the y that it gives. So this is like a picture of all the possible solutions. And we see that this line goes right through our data in sort of an optimal path. So we call it the line of best fit. So say we wanted to know what happens if we pick 29? Well, we don't have a data point for 29 specifically. And so we could use our line of best fit to say, oh, well, it'd be somewhere around 96-ish. And so you're able to sort of get additional information based on this, assuming that your R is justifiably high. And so, or close to 1 or -1, that is. So, all right, so that's how we graph the line. It's not too crazy. You just pick 2 points, put them down, and then just draw a line through them. You're going to want to make your graph pretty nice because if you don't, graphing and things is going to be a big pain to do this. If your scale's off, you want a very consistent scale because, yeah, it can look really screwy and weird if you don't have a good scale going. So, okay, that's how you do all these parts. Now, we're going to do it by hand. So I've taken the liberty of just adding the formulas here, but you would need to know to go and get these formulas. These formulas weren't provided on the study guide. You would have to know to go and get these. And looking at these formulas, so if we wanted to calculate the line of best fit and calculate R by hand, we're going to need some stuff. We're going to need the sum of y, the sum of x squared, sum of x times y, all these things. Anytime we see one, we're going to need that. And so there's 2 ways to get these. The first way is this hybrid calculator way, which is the way I hope you're allowed to do if you do have to use the formula. So what you can do is you can actually come in, put your data into the 2 lists. So we have list 1, list 2. Then go to stat, go to calculate, and then there's this 2 variable statistics. You hit enter, and in here you have list 1 and list 2. And you just put those in and you hit calculate, and it produces all of these sums that you need. You don't have to calculate these by hand at all if you're allowed to do it this way. So you can go sum of x squared is equal to this. And so look at this. There it is. Sum of x squared, our sum of x is right here, 169. If we come down, we get the sum of y squared. So there they are. And then if we come all the way down, we get the sum of x times y. So that's how you would get these using the calculator way. And then you can plug these right into this formula, which we will do. This is also great if you have to do it totally by hand. A great way to check your work. Okay, so let's look at how to do it completely by hand. So here we have x squared, y squared, xy. These are all the things that we need in order to plug it into these different formulas. So first I list out all my x values. So if we look over here, let me zoom out. Okay, so 30, 20, 16, 21, we just write all these down. So these are all the x values. Then we take each of these x values and we square them. So here's the x squared. We take 30 and we square it and we get 900. 20 and we square it and we get 400. 16 and you square it and you get 256. So on and so forth. You do this for each single one. You square them all. And then for the y value, you go ahead and you just write out all the y values. Now keep in mind you must write them in the way the ordered pairs go. So the 30 and the 105 and the 20 and the 89, they have to be on the same spot. So this 30, 105, 20, 89. So we just write this going the same way. If you write 91 first going the other way, you're going to have problems when you do the x times y column. So please make sure you write them in the same direction. Just be consistent. So we write all our y values down, and then we go ahead and we square all our y values. So you take 105 and you square it, and you're going to get this. 89, you square it, you're going to get this. And you do this for all of them. You square each and every one. Okay, so once you have all these columns, what you're going to do is you're going to then, for the last one, do x times y. And this is where it's important that they match. So you would do 30 times 105. Or in fact, you could even go back to your original data and go 30 times 105 and write that. 20 times 89 and write that. 16 times 83 and write that. Okay, so you do it for all of them. And then at the very end, you're going to add all the results. Because we are not interested in the individuals. We're interested in the sum of y, in the sum of x times y, in the sum of x. We're interested in all these summations. So we add them all down. It's just a giant adding problem. It takes a long time to do by hand. And so you add them all up, and you're going to get values here. Now, this is where I see a lot of mistakes made, and people either type their numbers into the calculator wrong, or when they do it here, they put some number wrong, they write it down wrong, and it can be pretty frustrating. But this is a way to double check. And if you get your x's and your y's summations right, then you know that this screw up has to be a calculator entry or you wrote it down wrong somewhere. So we would add all our x's down. I got 169, and I did do this all by hand, and we see that it matched. So we say, okay, we got that one right. There's no difference, so we're very confident this is correct. And then I added this one down, and we see it matched, and they all matched. Fortunately, I didn't make any mistakes. But if you see a mistake somewhere, these won't match. And so this is a great way to sort of just check your work as you go. And maybe you're running low on time. You could just write the teacher, hey, I found that this doesn't match. It's not exactly as I expected it to be. I couldn't find the mistake. I ran out of time. I'm going to do the rest of the problem with these numbers. So at least the teacher knows that you were aware there was a mistake. It's very easy to make mistakes with this much writing of all these different numbers. So okay, once we have all these summations, we go plug them right into our formulas. So I've already got the formulas written out, but we just take the formula for A, and it says it wants the sum of y. So here's where the sum of y would go. And you literally just copy the parentheses exactly as they appear here. Like, don't change anything. Just copy it all the same. Just fill in what goes there. So sum of y is 633. So we put in 633. Sum of x squared is 42091. So we just put that in, 4291. Minus sum of x is 169. Sum of x times y, that's this column. When we add them all up, we get 15525. So we put that there. Now our n is our number of data points. So, or number of ordered pairs. So we could come up here and just count these. We have 1, 2, 3, 4, 5, 6, 5, 6, 7. So we have 7 ordered pairs, and so that's why n is 7. It's not the total number of numbers. It's the total number of ordered pairs. And then again, we have sum of x squared, and then minus. Now this one in the parentheses is just sum of x. It's not sum of x squared like this one. In the parentheses, all that there is sum of x. So we put the sum of x there, and the square goes on the outside. And when you plug this onto your calculator, let's go ahead and do that. So we're going to clear this. So it has a fraction, so I'm going to hit the fraction key. So I'm going to hit alpha F1, has this little green F1 here. So we hit the green button for that. We can type a fraction. And then on top, we just write it in exactly how it looks. So we put parentheses all the same. So 4291, and then we do minus parentheses 169, close parentheses, open, 15525, close parentheses. On the bottom we have 7 parentheses, 4291, close parentheses, minus, open, parentheses, 169, close parentheses, square. And just make sure, I would go back and just look at what you wrote in, and we hit enter. Now we get a fraction out because I use the fraction key. In that same F1 menu, so if we hit the green key in F1, because it's green, we can come down and we can convert fractions to decimals using number 4. So we're going to choose 4, and we get our answer. And we see that it matches exactly what the calculator gave us for A. And so we see that we did it correctly. And you would go ahead and you would do the same thing for B. Now, if you notice for B, the bottom is actually the same. So what you can do is you can actually come up and copy A. And just to sort of point it out, see this is exactly the same as this. So we replace the top with n, which is 7, times the sum of xy. So we put parentheses, sum of xy, minus sum of x, times sum of y. So we just put those two summations multiplied by each other. Again, copying the parentheses and just taking our values from here or from here, whichever way you used. And then we would just type this in. So the bottom's the same. So I'm just going to come up to the top and just come over here and start writing it in on top of what we have. So we have 7 times 15525, close parentheses, minus parentheses, 169, close parentheses, open, 633, close parentheses. And then we want to just go ahead and delete everything else off the top. So there we go. We've adjusted it. Hit enter. Again, we need to convert. So we hit alpha F1. And we choose, whoops, we select this, make sure it's in your answer. So make sure it was, and we want to convert this thing, f1, from a fraction to a decimal. And there we go. We get 1.15. If you didn't mess up like I did, it'll say answer here, which is the last thing you had put in. So that'll work too. So we get 1.15, and that's exactly what we got. And if we look at our calculator answer, we see it's right there. So we have verified this thing using two methods. So we put a little check mark. In fact, we'd have a check mark here as well. Now for our final one, R is a bit of a doozy just because it's so big and long. But again, it's just plugging in. So you have n, that's 7, sum of xy, minus sum of x, sum of y. On the bottom is where I see a lot of mistakes. So these brackets are the same thing as parentheses. It's just we write them differently so it's easier to read. But on the calculator, you would just put parentheses for those. So we have n, and then again, times the sum of x squared. So here's x squared, there's the sum. So we put that in. Minus, now this is just the sum of x. The square is on the outside of the parentheses. So we put the sum of x, and then we square that. I see a lot of mistakes with this. People either miss parentheses or they put the wrong thing in the inside. So just be really, really careful. And then we have n, which is 7 times the sum of y squared minus, and then we have, again, just the sum of y is on the inside. There's no square on the inside of the parentheses. So you just put that, a square goes on the outside. And we'll go ahead and put this in our calculator. So this one, when people mess this one up, it's usually because they missed some parentheses somewhere. They have like an open parentheses, but not a closed one. Or they have an order operations thing. So if you just type it exactly how it looks, if you wrote it out correctly, you should be able to just plug it right in. So we're going to go ahead and type a fraction. So that's our F1 key, green key F1. And on top we have 7 parentheses 15525 close parentheses minus 169 parentheses again 633. So there's our top. We come down to the bottom. Everything is inside of a square root on the bottom. So I'm going to type the blue key since the square root's in blue. So blue key, square root. And then again, this is just a parentheses. We just wrote it different so it's easier to read. So we put parentheses 7 and another open parentheses. We got to do the same types of parentheses. So we do 4291 close parenthesis minus open parenthesis 169 close parentheses, square it, and then we close parenthesis again for this bracket. And another open parenthesis for the next bracket, 7, open parentheses, 57645, close parentheses, minus, open parentheses, 633, close parentheses, square it, and one more close parentheses for this bracket. All right, so we should be able to hit enter, and we get our R value. So if you get an error here, you're probably like maybe type something wrong, maybe you missed a digit, maybe there's a missing parenthesis. Just go through and sort of check it out. And we have our R. And so we've checked it two ways, because look at this is what we get using the calculator. And so we say as expected, of course it's that. What else would it be? We're just using multiple ways to verify it. And that is how you do this. If you have any questions about this, let me know. If you're a Citrus College student, good luck on your finals, and stop by online tutoring if you need any extra help. And we'll catch you in the next problem.